Hello and a warm welcome back. Today on the bench again is the Big Tech transformer that I'm trying to rewind, and to try and fill in this little divot here I'm again going off P-stone, not doing it as per the Tektronix spec sheet and everything. I've just got to wind 10 turns in here, and this is especially got to be insulated to a high degree, not that all the other windings haven't been, in that it's got to withstand about minus 1500 volts. And basically what it is, it's the heater winding for the cathode ray tube. To sort the insulation out, I've got a couple of, I bet you can't see it, couple of bits of mylar insulation. So I've already got one bit on. I'm going to wind the 10 turns on and then put that on top, and then on top of that will go a load of Nomex, because this underneath here, this 140 volt winding, and the other ones that's going to go on top are the ones that failed in the past. So I'm hoping to be able to, you know, chuck a load of insulation in between there, although we're getting very close to the end of our winding window. Scary stuff. To wind it, I'm not going to use the counter. I can count to 10 hopefully, although I struggled the other day, and I won't be touching the wire with my fingers. I'm going to be using the cleanest T-tool that I've got, which is cotton. Really, for really high voltage windings you should be using cotton gloves. Haven't got cotton gloves. Nearest I've got is the cleanest T-tool in the house. Be a bit careful with this first turn. Yes, I do realise I just touched the wire with. Just got to be careful I don't pull the wire out through that sleeve in there. Right, and the other thing, details. This is about 3/4 of an inch wide. I've got the first winding right over here, which is like the end of the mylar tape, so I need to move that first winding over here. So I'm just going to get me first few windings on, then we'll crack on. That's the CRT heater winding wound, which will fill in this gap as mentioned. I've got it double insulated, so we've got some of this, I don't know what sort of, it's PET tubing at the start of it. I've got PET tubing going through there, and then there I've got some DMD insulating material. Underneath there is some Nomex, which was insulating the turn that was coming off before, plus tape, etc. Now all I need to do is put the final bit of mylar insulation on top, just to make absolutely triply doubly sure. Ideally I'd have liked the terminations to go out here, you see, because we've got a bit of a dimple. However, what I'm using as a guide to site where the terminations come out is this, which is the terminations board that goes on the transformer. So here is our main side, and this winding is 2425, and so originally I was going to bring the terminations out here. However, then that means they're going to go all the way over there, so it just made more sense to go there. In the end it doesn't matter, because the windings will finish about here. And it doesn't matter if this is sticking out over the bobbin, really, as long as it fits within the old transformer casing thingy. There we are, another sunny day in Lincolnshire in England, winding transformers again. We've got some really fine stuff, 0.25 millimeters, 30 gauge, and we need 280 turns of that, and I can't remember what voltage it's supposed to be. We've put the EHT winding on to power the heaters on the cathode ray tube. That's well insulated, really well insulated. This winding is going to be tricky. It's of such a fine pitch that I don't think I'm going to be able to 100% not have cross turns on there, which is a big no-no, but I just can't see any way that I can do it really. And it's not going to be all that neat, so but I'll do the best I can, and who knows, I might be able to do it really well, but we'll see. So I'm going to whack a load more turns on and see you in a bit. Ran out of battery there, so I couldn't film that really thin stuff. Anyway, I just whacked it on, covered it in some yellow tape, and then I've put some very thin Nomex. Only got a little tiny bit of it on between all those layers, and I am feeling a little bit more hopeful because that's what the winding window we have. This and another one of exactly the same amount of turns, i.e. 177 turns, or the last high voltage ones to go on, and then after that it's all heater windings. And because I put windings on not in the order that went on the original tech transformer, a lot of the other windings that went on top on the original tech transformer are underneath there, already sorted. So yeah, these are the last few high voltage windings to put on, and I'm feeling a bit more hopeful about getting it all on, although some of the heater windings are doubled up. In other words, instead of just having one turn of 17 gauge, you've got two turns of 17 gauge in parallel. We'll get to that later though. Getting there anyway, we're not far off the end, lads and lasses. That's 52 turns on of the 23 gauge. Oh god blimey, what is that? 0.56 millimeters. As you can see here, hopefully, I've got a big gap. Rather than trying to force that over there, I'm not going to do that, because underneath here the windings underneath sort of go ramp up, and so there's a bit of a bulge here. If I was to force them up there, then that would just accentuate the bulge, you know, going up. Sometimes it's just a good idea to let the windings find their own path, don't force them, and just sort of, it's a bit like working with wood. You've got to work with the grain, or in this instant working with the windings underneath, etc. Hope that makes sense. Hopefully you can see that bump there. We've got like a divot there, a bump there. It's all over the frigging shop, but yeah, I've just got to live with that. I'm not taking all the other bloody windings off underneath. I'll try and wind round this bloody camera tripod. As you know, there's not much room in here. What I found with using this setup, right, I've just chucked on 67 turns in about 10 minutes, so it's not that hard. So with a hand winding setup, you can do quite a lot. What I've found is that I don't really need to do, oh no, you can't see that, I don't really need to guide the wire that much. The wire guides itself. See, my finger ain't, my thumb sorry, isn't doing a great deal at all. Probably go faster than that. See, I'm not really doing a lot. All I do occasionally is, I don't know. All I do occasionally is just move the wire. Oh, you can't bloody well see that, can you? All I do occasionally by sight is move the wire a little bit over there, a little bit on the other roller, a little bit there, and then occasionally I just put a bit more or a bit less tension than is needed. So yeah, I just move the wire a little bit over, and yeah, the transformer winds itself. So you don't, what I'm trying to say here is that you don't need a big fancy pants Arduino mechanical monster of a winding machine that you're only going to ever use like what, once every month, every year or something, to wind really good quality transformers. Yeah, I know this is a bit gash, but you know, this is a very complex transformer compared to say like a audio transformer, an audio output transformer. It can be done with bugger all. The other day on Mailbog I mentioned I wasn't enamoured with these narrow bobbins that the wire comes on, and that it might cause problems, and it is starting to cause problems. Cut that out obviously. So I don't know if you can hear it. Oh, I stopped doing it now. What's happening is, because the wind isn't brilliant on here, there's like loose wire, and the wire is getting trapped inside this narrow bobbin. So when I would think the Brocut, like I'll get the wire off, get like a massive big reel and then wind it onto these little reels themselves. But as you can see, the winding tension is all over the fucking shop. I haven't backed that off or anything, that's just like what comes on there, and it's getting trapped underneath here. So I shall be writing a email to them, or I might even send them a letter. Let's go old school. Here I am the next day, just finishing off this winding. I've got 3 turns to go. Hopefully you'll be able to hear the binding that's going off there. I'll try and get you a better shot. A bit hard to, because you're writing me why. Right, that's really binding up. See? That's binding there. Which means what I've got to do is take off some of the tension here, and then just use my fingers to tension it, and then gently as I go along. I mean, you can see, look, hold on, you can't see, can you? You can, no, I'll just get a pointy. You can see the winding isn't tight, like it's so loose. It doesn't come off the bobbin properly. That's the end of one winding. I've put on a couple of turns more than what is necessary. I've put on 107. The RAF are at the bugger again. I put on 179 turns instead of 177, just in case. Better to be over than under. You get miscounts and things like that, so best be on the safe side. And then now what we've got there, I've cut the last winding. Now we're starting the other winding. And essentially in the power supply, these 2 windings are connected in series to create, what is it? Let's call it 180, 360 volt winding altogether. But the tap is used to create the Positive 325 unregulated supply. There's a lot of supplies in this scope, so yeah. So we'll need that tap. I'm not quite sure how I'm going to terminate it yet. You see, really, it's just a tap, and on the top of the transformer, where are we? We've got 510. Hold on, 510 74. Oh, sorry. 510 7. Oh, it's 14. Is it 14? Yes, sorry. 510 714. So they would be connected across there like that. So we could do that. We could bring out 2 wires, but then that is creating a bump, which okay is not a problem. Do we need to? So I could solder it. I could bare the wire there and solder it, create a joint and just bring 1 wire out, or do I take 2 wires out? Not quite sure how I'm going to do that just yet. So while I'm just sort of in the mood, I'm just going to continue winding, and then I'll figure that out later. Oh, and because they are tapped, I don't need to isolate the 2 windings from each other. Terminating windings is one of the most difficult bits of winding. Finishing a wind, starting a wind, all tricky, but yeah. So looking at the original Tektronix transformer and how they constructed it, you can see that they use sleeving all the way through to the termination. See there, and so forth and so on. However, obviously if you've got a great big bit of tubing, I mean this is heat shrink, they didn't have heat shrink in them days, they just got that wax plastic covered cotton sort of thing. You got a great big bump. Again, not important because there's going to be no laminations here, but it's important from a winding point of view because then your turns don't sit nice and lovely. So in light of that, after rummaging through all my various tubing and whatnot, I started to get my head around the subject and do what I've done before, which is just use which is to use some Nomex, put those through there, put some tape on top, and that will do the job just as well as sleeving, and we won't have that big bump to wind over. So to do that, I've undone my temporary bit of tape that was securing the 2 ends to finish one winding and whatnot the other one. I'll get that there. You really need bits of tape all over the shop because you never know when you just need a little bit of tape, like I've got here, just to secure the ends to stop it all unraveling. Right, now I can put that back over there, and then just to get a nice 90 degree, just put my thumbnail there. Now we've got a couple of bits going out, and to try and stop them, no, we're not got that quite right. That one's going a little bit too forward. We're trying to go, where are we trying to go? Really are trying to do this around this fucking camera. Right, I'm off piste. We want to be somewhere there. And where's my bit of paper gone? Right, well first I've got to try and shove them through that hole. It's all good fun. I'm going to make sure you get the right hole, as the actress said to the bishop. That's one. Where's the other bit go? That's the other thing, trying to keep your winding or your wire all nice, of what, you know, you get bits in it. Not as lovely as I would like it, but there we go. Right, now we've got the really fun bit of trying to get that underneath there. Really helps if you've got some like tweezers and other implements of manipulation. I'm going to sort that out off camera so that I'm happy about it, and then I'll show you the last bit. Are you going to focus your bugger? I'm a bit happy about the dressing of that. Not 100% happy because they're not symmetrical and lovely, but they'll do. Now I've got to get rid of my temporary bit. Find somewhere to stick that. Now I've got that over, I've got my little bit of tape handy. There. Of course I bet you can't see a damn thing. There. Again, not 100% happy. I'm never 100% happy, but you have to sort of go a bit easier on yourself, and it'll be fine electrically, insulation wise. Now I've done that, by rights these two terminations here of the windings should have separate insulation, because they should go to separate pegs on this board here, but then they're connected across that anyway, so yeah, actually I'm going to go and check my pictures, and just to check that, I'm not quite sure whether they're joined on here or somewhere else on the scope. It really doesn't freaking matter, and it would be far better if I can just insulate both of them and just bring one out, and you know, save a lot of sodding about. But Tech did it for a reason, I don't know, so I'll look a bit more into that and then decide what I'm going to do next. In the control room, these are the pictures I took of the transformer before I took it apart, showing all the connections. I'm going to zoom you in. There. And what we're after with these, so these are the windings that run about, I can't exactly say, I think that's 7, 14, 5, 10, but as you can see there's a sort of bar, bus bar, shunting bar joining one of the terminations to the other, and then it looks like we've either got 1 or 2 wires coming off that, and there's no wire going to that one as I can see, so I can basically bring those out under one where do you call it, one bit of sleeving instead of 2. If I've just edited and managed to get my head around the software, it just showed you me winding this in a really quick time. Yeah, we've got a few gaps and everything. Yeah, whatever. I'm trying to get rid of some of these umps and bumps, but you know, we ain't got that long to go. This is the, as mentioned, this is the last high voltage winding. I got to about here, and for one reason or another I got like a big gap, so the turns were falling really, you know, down sort of thing. So what I've done, I've put a bit of lacing, sort of, I don't know, some sort of flat nylon stuff, just to fill that gap, so that I can get a few more turns on, and then I've got about another 30 turns, and then that's the last high voltage winding done, and then we can get on to the heater windings, the low voltage windings, each of 10 turns each, and I'm feeling confident that we'll get them all on. We'll see. Never say never. Right, that's another 4 turns on, and they're not falling down a crevice, and it means that when we wind the turns on top of this, that we haven't got this bit we can't use at the end there of the bobbin. We might need every single millimetre of space or whatever. Right, Kalukale, come on you bastard, focus. Come on. Kalukale frabjuste and all that. We're nearly at the end. I ain't got much, but I think I'm gonna be able to get all the turns on. How many turns have we got to get on? We've got all the high voltage turns on, and a few of the ones I've stuck underneath there to fill in gaps, so there are less turns to put on the top as per if I'd have followed the tech way of doing things. Let's have a look at what we've got to get on. Not many. 10 turns of this, 10 turns, 10 turns. These are all the heater windings. However, a lot of them are quite high current, like 6 amps and stuff like that, and it's not quite straightforward. So 1726, 10 turns of 17 gauge. 17 gauge is 1.15 millimeters. So this thick stuff, no worries there. Whee! No, sorry, this stuff, this thick stuff, yeah. 10 turns, 10 turns, and then we've got 10 turns, but it's not just 10 turns, it is actually 20 turns, but sort of in parallel, of 18 gauge, which is 1 millimeter, which is what I wound the primary out of. So that's a little bit more complicated. Again, 17 gauge times 2 times 2. 10 turns, 18 gauge. Sorry, my fucking hair gets everywhere. Pardon my French. And then we've got 10 turns of 19 gauge. Well, I don't know. I probably have got 19 gauge, but I'll just use bloody 18 gauge and sod it. And then we've got 26 turns of 17 gauge, which is a little bit different, but there we go. If we look at the end winding, this is the original windings. As you can see, oh sorry, we've got Tech have basically left like a gap in between some of the low voltage windings. I'll see about that. I might just use tape. I mean, obviously the tape, oh sorry, you can't see. As you can see, like, Tech have left gaps in between the windings. A lot of layering going off. I mean, this is the insulation material here is like a woven sort of fabric. Yeah, you can see why, like, the insulation breaks down on these things. I mean, this is what, like I say, nearly 60-70 years old, so I'll see about that. I'll probably just use Captain tape. We'll see how we go for space. Before I start winding properly, I've just got some old sort of wire in there that I probably pulled off an old transformer. So what I'm going to do is wind 10 turns on, so that I can then measure off some of the wire off some of these bobbins, and then I can wire them in parallel, as it were. I think it's going to be fun and games terminating them. I mean, I've drilled enough holes and everything, as you saw way back, but yeah, there's not a lot more holes here, so we might need to be a little bit inventive there, but we'll see. So I'm going to wind on 10 turns of this scrap wire, measure it out, then cut some off to get the, you know, the 2 parallel turns on. Sorry, that should have been 2. But before I do that, after I've done this, I'm going to put some Nomex on there, just to make absolutely sure we've got good insulation between the turning underneath. But because this is really thick gauge wire and it's going to be going on under quite high tension, then I want to make sure that it's not going to dig into there, and so this will give us like a nice sort of layer to wind on. Well, that's the first turns, the first 10 turns of the first heater winding. Didn't take long at all, pleasure to wind because it's such thick heavy gauge stuff. Terminating it takes a long time because yeah, it's such heavy gauge shit. So sometime later, that's the first big heater winding wound and terminated. As you can see, there are a lot of terminations. Winding takes very little time. Terminating properly and all the insulation takes a lot longer. So that is winding, what are we, 2617. What we got next? 2617. 916 is exactly the same, and where I terminate it depends on looking at this. So this is what I'm using as my template. There's a primary. What were those last 2? So there's, as you can see, there's a lot of windings. Very complicated transformer. So 2617. The next ones we've got a 916. So obviously, right, 916 are just above there. Obviously, when tech specified the winding of this and all the terminations, they used the brains. There was some sort of thought going off about this design. It wasn't just randomly set up this way. So I need, if I can, to take the next winding out this. I need to take the next winding out this way, and then I'm hoping that the next windings go out this way, but we'll see. It's just a case of winging it, using your head, and there we go. To secure this big heavy gauge wire, I'm using this is fiberglass tape. It's got a really good adhesive. Doesn't look pretty, but at least that secures that, and when the next winding goes on top, then that will secure it even better. I've just got a bit of very thin gauge 5,000, well, I don't know what that is in millimeters, Nomex underneath there, just to insulate from the windings underneath. I'm using Captain tape, which is more than adequate to insulate against 6 volts. Compared to the high voltage windings, it's bugger all. I'm not using a counter, I'm just counting the turns by, you know, using the old noggin. What I have had to do is lower this sort of roller bar here, because when it was up here it was just putting too much tension onto the transformer windings. So I'm winding with a glove. Oh, sorry. I'm winding with a glove to get the, you know, basically because this heavy gauge wire is hell on the hands, and then I am putting pressure. You can't see, I'm trying to hold that hand up. I'm using the thumb to deform, put a kink in the wire as I go along. Like I say, it doesn't take long. Keeping a little bit of distance in between the winding before and this one, and I am really deforming this wire as I go, and there's a hell of a lot of tension. That's why, one of the reasons why I use that thick Nomex. And there's some reek tension in there. I've got very strong hands anyway. I don't look like much, but very strong hands from playing the guitar and working with my hands for years. Although it is knackering. Yeah, it does bug your hands up. And they're nearly 60-year-old hands, so you can see it doesn't take long to bung on. 10 turns, but you just need to, well, I need to keep stopping for a little while. As you can see, it's deforming the Nomex, but I'm not bothered about that. I've no idea what that is. I'm yakking on and not really counting, but looking at the last one, that is probably about 10 turns. So I'm going to, let me just see, I'll just do a quick count. 1, 2, 7. Right, I think we need another 3. I'll bung on another couple of turns. Ooh. There we go. We should be about there. Right, I'm going to count those off camera because filming this, all these videos, just filming all these videos does add a lot of time onto the job. It makes the job about 3-4 times longer, and then you've got all the editing and whatnot. So yeah, some of it you just have to take my word for it, and it's easier for me to do the job properly off camera. Right, well the next one is again a departure from Tech's way of doing things. On the Tech plan, we should be bunging on a parallel 18 gauge 1mm 10 turns 2023, but as I'm winding the bugger and Tech ain't, I'm going to go for 33-34, which is 17 gauge, and that is 26 turns. We've got 2 10 turns there. 26 turns may just like fill most of this up. Unfortunately, I would have liked to have taken all the terminations out there, but our terminal board 33-34 is like there, that end. So it's looking like a space spider's arse at the moment, like with all these heater windings coming out. I am really glad that I bloody drilled all these holes beforehand, because the thought of having to, yeah, don't even go there. Yeah. Anyway, onwards and upwards. Raw. And with one more label, each one can't. That's another winding done. Just hope these buggers don't fall off. they shouldn't do. So let me just have a quick reckoning up, see how many we've got to go. That's probably me done for today. I wasn't going to do that winding, but I went and had a sit down, cup of coffee, chilled for a little while, and then I come back and had another go at it. Anyway, that's that one done. So we've got 10 turns of 2 times 19, which, as I mentioned before, I'm going to use 18 gauge. That's done, that's done. So we've got 5, sorry about that, we've got 5 more windings. It says 10 turns, 10 turns, 10 turns, 10 turns, but these, oh no, apart from that one, yeah, these are all parallel windings. So 10 turns read 20 turns, 20 turns, 20 turns, 20 turns. That's a layer, at least from what I've got on this one. So that's another layer, and then we've got another 2, yeah, another 30 turns after that. I think we should be alright. Got plenty of, mind you, if I just get some sort of flat thing. Yeah, we've got what, about 4 mil. All the batteries flashing at me, and we've got a bit more over here, and same on the other side, so we should be fine. Right, gotta go. I think I'm going to wrap it for this one. Until the further thrilling episode, thanks for watching. Take care of yourselves.